Man's marvelous body is constructed for strength, as well as for free and graceful movement. This freedom of movement depends upon intricate systems of bones, muscles, and nerves. This film is primarily concerned with one part of the bony framework of the body, the spinal or vertebral column. This is the spinal column, consisting of 33 bones. The upper part of the spinal column is joined to the base of the skull. It is joined in a way that gives firm but flexible support. In this unusual X-ray photograph, you can see these parts of the body in action. Lower down, the bones of the spinal column serve as the rear supports for the ribs and their attachments. Together with the ribs, this column also helps to support the shoulder girdle. At its base, the spinal column is firmly connected with the bones of the pelvis. This supports the upper parts of the body and forms the upper connections of the lower limbs. A very important function of the spinal column as a whole is to provide a well-protected path for the spinal cord. This cord is the extension of the central nervous system from the brain. While the average spinal canal is about 27 inches long, the spinal cord averages only about 17 or 18 inches. A pair of spinal nerves appear between each vertebral arch. The fully developed spinal column usually consists of 33 bones. Each of these bones is called a vertebra. The bones are grouped into spinal regions: the cervical, the thoracic, the lumbar, the sacral, and the coccygeal. The sacral and coccygeal are shown here as one unit. In the adult, the 5 sacral vertebrae are fused. This shows how the assembled spine is positioned in the body. This is the spinal column in a reclining position. Note the location of the pelvis, or hip bone. There are 4 major curvatures in the spinal column. There is a convex or forward curvature in the cervical region, and another in the lumbar region. There is a concave or backward curvature in the thoracic region, and another in the sacrococcygeal region. Wedge-shaped discs of connective tissue help hold the vertebrae apart. The shape of these wedges account for the curvatures in the spine. The wedge-shaped discs of cartilage and the curvatures give elasticity to a person's movements and help absorb shocks. Openings between the base of the arches of the vertebrae provide entrances and exits for the nerves of the spinal cord and for the associated blood vessels. From most vertebrae project small extensions of bone, which form joints with similar extensions of the vertebrae above and below it. Other, more prominent extensions extend backward and to the sides to form spines to which muscles and ligaments are attached. These form joints which aid movements of the trunk and prevent the individual vertebra from slipping forward or backward. There are differences as well as similarities among the different vertebrae. For example, the first 2 cervical vertebrae are unlike any of the others. This one is called the atlas because it supports the head, as the mythological Atlas was thought to support the world on his shoulders. It lacks body and spine and has 2 large surfaces on which the skull can rock. This X-ray picture shows the action. The second vertebra is called the axis. It has a bony part that serves as a pivot of rotation for the atlas on the axis. The remaining cervical vertebrae are quite similar, except for the long spine of the 7th vertebra. The position of this vertebra may be easily seen when the head is bent forward. Taken together, these 7 cervical vertebrae in the spinal column help provide freedom of movement for the head and to cushion the head from shock. In the thoracic region, there are 12 vertebrae. Each of these 12 vertebrae is somewhat larger than those of the cervical region. These vertebrae serve as points of anchorage for the ribs. They permit the slight movement of the heads of the ribs that is required in breathing. In most people, the first rib is joined to one vertebra only. The next 9 join the spinal column at the joints between adjacent vertebrae. The 11th and 12th ribs, the so-called floating ribs, each is joined to a single vertebra like the first rib. We remove the rib cage to show the location of the kidneys, stomach, liver, heart, and lung. This is how the ribs form a protective housing for them. And with the 5 lumbar vertebrae, these bony structures form a partial protection for much of the intestinal tract. The lumbar vertebrae are larger and stronger than those above. Being lower, they are subjected to greater weight-bearing and strain. The lowest lumbar vertebra is joined with the sacrum. The sacrum, in turn, is joined to the bones of the pelvic area and forms a protection for the intestines, the bladder, and the reproductive organs. This cut section shows the inside of the spinal column. Ligaments hold the vertebrae together, help achieve firmness, and at the same time allow for flexibility. Inside the rear of the spinal canal, all the vertebrae are united by a ligament. Along the front of the canal runs a second and much stronger ligament. In addition to these, another ligament connects the bodies of adjacent vertebrae in the front of the column. Body muscles also have important functions in the maintenance and movement of the spine. The great sacrospinalis muscle on each side holds the spine in an erect position. See how it divides into 3 columns on each side, which become attached to ribs and vertebrae at different levels. The ligaments and muscles that attach to the vertebrae prevent the vertebral column from bending too far, thus affording a protective role in preventing damage to the nerve cord and a crushing action on the internal organs. The human body is a group of interrelated machines with the spinal column as their axis. Good posture means that the body is held erect so that the body mechanisms function normally, while position and balance are maintained with a minimum of muscle strain. Under these conditions, none of the curves of the spinal column is exaggerated. Slender and rapidly growing children often have postural trouble. 2 procedures may help remedy this condition. One is the use of food such as milk, which helps build stronger bones and muscles. The other is to make certain one gets plenty of rest. Bad body mechanics may be the result of stooping to avoid calling attention to excessive height. Good posture is merely the reflection of good body mechanics, and good body mechanics depend in large measure upon the intricately built axis of body movement, the spinal column. In this film, we have seen that the spinal column consists of 33 specialized bones grouped in different regions. We have also seen how the parts of the spinal column are related with other parts of the bony structure and with the nerves and muscles. The curves in the spinal column and the connective tissue wedges between the different vertebrae provide the flexibility and resilience required for movements of the human body. The spinal column is the axis of the human structure. It makes possible the body's wonderful freedom of movement and helps to give us flexibility and strength.